Quraishi, and today I will discuss about uh, GMASH, MATLAB and VISIT. So this is our simulation, and we read it from GMASH file, and using MATLAB we done the simulation, and in there the output is that you will read the temperature like uh, from here the temperature distribution. So we apply in the boundary. This is the 400-degree Kelvin, and the bottom is the 300-degree Kelvin, and this is the distribution how it is going to rise, and you see the fine meshing on there. So let's talk about how can we did it. So first we generate a mesh file in the GMesh. This is the mesh file, and later we read this mesh file in the MATLAB. Say the mesh file name is we say it try, and the output is that a dat file, that is it try dot dat. So this output file will store in my desktop this location, and the input GMesh file read from here. And this is the MATLAB code. I write it there, and how can I write it? So whole scripts I describe in this here. So you find this script in the descriptions. This is one of the project, uh, and you see how code description and there. So first I describe in there how I build the code. Step one, development of Lagrange basis function, and I describe in there, and derivation of Lagrange basis function. Step three is the formation of Jacobian matrix. In there is some technical terms. Step four is the master to physical coordinate function. Step 5, formation of stiffness matrix, and step 6 is the assembly. And the code description, that means you may see it, there is some function here. This is the Lagrange derivative function. This is the Jacobian matrix function, master to physical element function, stiffness function, assembly, and this is the this function from output a dat file dot dat file that is read in the visit, and this is the GRD that read the GMesh file, and in the main function we read everything from here. So, and this is the code description, and for the hand calculation, this is the hand calculation. You may see how the code is and the output is coming, and the hand calculation and the code result are similar, and that means we validate the code using our hand calculation, and assembly, and our output is there. This is the GMesh one, and the GMesh file, and the output is there. So let's talk about from the scratch. So you have to download this GMesh file from internet, GMesh. So open a new file. We say it's tutorial.geo. Okay, and we add the points of each point. So we say that 0, 0, edit again, 1, 0, again 1, 1, and another is 0, 1, and later here there is a description: shift to hold, E to end, and Q to abort. So we say Q to abort. Okay, and we form, there is 4 points here, here, and there. So now the second step is to add line. So we select each of the point and select it, again select it and finish it. And here Q to abort, I press Q to abort, and then we select the plane surface. So this is our plane surface, so select it and Q to E to in selection, Q to abort. So this is the plane surface, and in the physical group we say so our assumption is that we are applying this boundary and this boundary 300 Kelvin, and only this boundary we are applying 400 Kelvin. So for that we make line, so we select this line and this line. So E to in selection, Q to abort, and this line again select it, abort, and the surface, this is our surface. And okay, so now uh, we save this file. So my file is saving in my directory, computer directory. So let's go to the directory. Tutorial 0. So open it in the text file, and you may see that 0.1001001 and this one, and line 1 1 2 2 3 3 4 4 1. You can change from here, and line loops this one. So we say that this 4 1 2 is the tag 1, and 3, that means this line, we are describing that this one is our tag 2, and the surface, that means this surface is our tag 3, and we say plane surface is 1, so it is reading 1. Okay, and save it, and then again reload it. Okay, it's reloaded, and then say mesh today, so it is format this type of meshing in there. And so we save in there, so it's saved as a mesh file. Let's go to our directory, so here mesh file, and open it. So click on it and open in a text file, Word file or anything, and you may see it that our node is 5. So how can the node is 5? The node, this is node is 1 2 3 4, and this one is the 5. Okay, so node is 5. You see the number 1 node is 0 0 coordinate, this is x, this is y, this is z. Again 2 is 0 1, and the 5 is the middle one, 0.5 and there is something you have to know it. The element is 8, and it reads there is in the second row you see the 1 and 2. So 1 means this is one dimensional, and 2 means this is two dimensional. That means 1 represent the boundary. uh, so how can we read this? This is one, the element is three types, 1 2 and 3. So 1 is the one, a line, straight line, 2 is the triangular, and 3 is the four dimensional, and its coordinate you is finding from here. This is 1 2 3 4 5 6. From 6 to 7 is the coordinate. So line 1 is 1 2. You see line 1 is 1 2, line 2 is 2 3 3 4 4 5. You see from here 1 2 2 3 3 4 4 1 again. And line 2, this element types 2, and its coordinate is 2 3 5. That means from here elements 2 3 5 2 3 5. Okay, the another element like this one 154. So 154. So you may understand how. And our tagging is stored in here. Okay, the tag is there. This is 1, that means this line, this line is the 1, and this line is the 2. You see, 1 1 2 1, and the 3 is the surface. Okay, 3 is the surface. So this is most important. You have to know that which column is represent which number. This is element type, this is tag, and this is the coordinate of each of the elements. Okay, so our meshing is done. Now our work is to go to the MATLAB, and in the MATLAB we read the tutorial, say tutorial mesh, and it will produce the a file is called tutorial.dat. So we run it to, okay, so it's run. So it is really takes less time. So in the directory you check that is there tutorial.dat file, so it is produced here. And let's go to the visit file. So first I have to close this thing. Okay, so I open it and I am reading the tutorial.dat, and you have to first check up this one, take plot. Of course you have to find it, take plot, and give the path in there and say okay, and go to the add again, pseudo color, select Z, draw in there. Now you see the temperature distribution in there. So, and you can also see the mesh drawing there. This is the meshing, and you also see the levels. The mesh level is not shown here. So let's go to increase the mesh file meshing. So here here we say that refine by splitting. So it is, you see it is splitting again, again. So it is lots of meshing in there, and again we save it, and then we are again read it from MATLAB, and it is producing the mesh. It takes some time to read it, and it's read it. So again we go to there and reopen it. You see, reopen it, and it immediately generates some lots of levels. You see there is levels, different types of levels this time. And you can also visit from here. It's a nice visualization, you may find it. Okay, now you can produce this file from you may save this file from here, save window, and it will store this view in your directory. Okay, now let's talk about the MATLAB code, how it is coded. So first we code this function, this is called Lagrange derivative function, and in the Lagrange derivative function we describe in there how the Lagrange derivatives come. You can modify the code if you know this, the basics. So first we develop of Lagrange basis function. So we take a small triangular element and keep this is number 1.2, and this one is 4. This is our master element R and S, and XY is the physical element. And from the definition of the Lagrange basis function, this is the second Lagrange basis function, A plus BR plus CS. So for 0 1 we apply 0 1, so that means this is 0, this is 0, so A equals to 1. Again we apply 1 0 b equals to -1. So in this way conditioning we find 1 2 3. That means this point we find Lagrange basis function, this one. In the second point we find Lagrange basis only r, and the third point Lagrange basis function is only the s. And from here grdx you have to know how, what is this thing. So in the MATLAB function you may see the each of the function in the input mainly is grd. So each function is the input of the grd. So grd is the whole package of data structure that takes all the elements x, y, icon, boundary condition, tag, Lagrange, Gas quadrature point. Each of the thing are included in the GRD. So when you call the GRD, that means you are calling each of the parameter. So from here, the GRDX is comes from this x coordinate, x coordinate, x coordinate, and x coordinate, and similarly the GRDY comes from here. And GRD icon. So this is the GRD icon is formed. This will be the element one, and element one you see point 1, point 2, and point 3. For the element 2, and it is point 2, point 3, and point 4. So GRD icon row, in the row, the number of row is the number of element, and the number of column is the number of point. That means it is always constant, the 3 number, as we are forming triangular mesh. And the boundary, that means boundary, this one is boundary, this one is boundary, this one is boundary, this one is boundary. So it is point 1 2 1 2 2 3 3 4 4 1. And the tagging, again we say that this is one tag. It is depend on the user and the boundary condition. If you apply it in their different then the other condition, then you say that this is tag 3, tag 1, tag 2, and according to the question. And here then we derivative of Lagrange basis function, we derive it with respect to r and s. So we are derivative these three functions, so that's why we find in here psi 1 with respect to r, psi 1 with respect to s. There will be s, I forget this one, there will be s. Psi 2 with respect to r, psi 2 with respect to s, that means with respect to r that means 1, with respect to s that means 0. Here same function. And the formation of Jacobian matrix, this is most important. You have to understand what going on the Jacobian function. So Jacobian function, why we format this function? The answer is that when we convert the master element, that means this is the master element r and s, to physical element x and y, we need a inverse Jacobian. This is the master and this is the physical. So inverse Jacobian helps to convert this thing to this one. So that's why we need Jacobian matrix. So Jacobian matrix is the uh, x with respect to r, x with respect to s, y respect to r, y respect to s. So here k means Gauss quadrature point. I will discuss this later. K denotes the Gauss quadrature point. And here x is the x, definition of x is comes from xm ym. That means if you derivative is with respect to r, it will be with respect to this one, like this one from here. So here m denotes the this type of index 1 2 3 1 2 3 here. And at the end we form the Jacobian and inverse Jacobian. You know the inversion and the determinant. Okay, and the formation of stiffness matrix. So okay, we also talk about so in the Jacobian function, our input is the GRD and the element number. So first we form a loop from I1 to 3, and the point, read each of the point of the elements per here. You see each element it reads the each of the element point. and it forms, so we call the Lagrange derivative function. Here we form the 1 2 3, and inside there is, instead of r we say grds, so it is calling grd and form the -1 function. And here it is, so it is calling x at the point, y at the point, that means it is going each of the element, and it form here Jacobian matrix, and this is the inverse of Jacobian, this is the determinant of Jacobian. And later, so this is the master to physical element. So again we call the grd element and aj variable, and we call the Jacobian and Lagrange derivative, and the inverse is converted to the this Lagrange derivative to the, we said this side, that means this is physical element. So the physical element one matrix, the element of one is the x and element two is the y. Okay, so now let's go to the formation of stiffness matrix. If you cannot understand the thing I calculate, hand calculation, I request to read the hand calculation, you can understand easily. So, and how the each element comes in from here, and there is some calculation, you may you may see it and you can understand the theory behind it and assembly. Okay, so now go to the stiffness matrix. So in the stiffness matrix, our formula is the this one. So we calculated, and here we want to form a weak formation matrix. So that's why we multiply a weight and summation on the domain x, y, z, and later we break it, and then it is going to, this is a quadrature formula we apply on it, and later here there is some condition, and then we find the formula in there, that means this formula, and there is c, we say conductivity of material c. In the MATLAB function you also find a, yes, C, the conductivity. So for now simplicity, we say that conductivity is 1. In the later, you can define the material conductivity 100, 200 according to the, according to your requirement in there. And then so the formula is our conductivity multiply uh, Lagrange basis derivative with respect to x, this is d, and with respect to again this is x with respect to j, and this is a Gauss quadrature point, and this is the determinant of Jacobian. So this is our main target to form this uh, stiffness. So I also show in the stiffness in the, in here, elemental stiffness matrix calculation in there. My colleague, Mr. Babatunde Ali, he helps me a lot to write this program and in the hand calculation. So this reference also goes to him and me and Dr. Arash. So this one is another. This one is the formula for forming this stiffness elemental matrix, and so you need the Jacobian determinant and Lagrange basis function and other thing. So for element one, we calculate from here. You find this thing from here. So just see it and you will understand the whole thing. So let's go to the code. So here we form the elemental stiffness matrix. First we form the zero matrix for the allocation of the memory to relocate this data from here, and it is reading the element is the grd icon 1, as I told you that row first icon in the icon matrix, the first row is the element, and the second row is it read the different types of elements, and it is looping over the element, and there is two variable d and m as mentioned in there. D and m here. So D and M here, D and M. So we have to format this formula in the MATLAB. And here, so we call the master to physical element. Later we call the Lagrange length of Gauss quadrature point. So Gauss quadrature point, we form the Gauss quadrature point in there. And this is the Gauss. For the second order Lagrange derivative function, we take this from internet, this value. And later uh, we call this Lagrange derivative function and form the Jacobian and call this thing, and we write this thing from the formula. Again, the assembly, so assembly is going there, so it is allocate the memory, the assembly matrix shown in there. Here is the assembly matrix. So as our element is 5 for the initial stage, so we say that this is one 5 by 5 element, and it is storing the element in there. So for the assembly, I discussed the assembly matrix in my previous video. You may see it about how can it format it. And then in the write text plot function, this write text plot function, so it is producing a date file, um, and it is reading grdx, grdz, and there is some function that new line, and it is allocate some digit in there, so you just see it in there. And the grd this file read the GMASH file, so it is input is file and the grd. So here this code we take from MATLAB, and later we modified it, and it is reading different types of element. Okay, so at the end we call all of the function in the, this is our output function tutorial date, and this is our input from the GMASH. And in the boundary we say that this is the tag number, and we are applying the in the boundary condition, this is our boundary condition. So you may modify it, for example in the tag 2, this one, so it is comment out, this is not the actual thing, comment. Okay, so 1 and 2 in the tag 2, we are applying sorry, in the tag 1, yeah, tag 2, we are applying 400 degree Kelvin. So for the scaling purpose we use 4 instead of 400, so that it will give a nice visualization. And this one is uncomment, or so you can use this one as well if you make the, if you want to apply in the surface. For example, tag number 3, you can say this is tag 3, and you can define how much temperature in there inside this. And the other tag, that means tag in the boundary tag 1, it is applying 300 degree Kelvin and it freezes. So for your purpose you can use this tag and visualize it. So at the end we are calculating temperature. So let's K, that means stiffness matrix divided by boundary condition. So you may see the temperature in there as well. Here the temperature. So our first temperature is 3, and the last temperature goes to 404. So if we read another one like 9th, so this is the simple case as I mentioned before, the 300, and it is increasing different region, maximum is 400. So yeah, you can read this thing, and our temperature is plotting at the z coordinate, it is looping over. Okay, so thanks for watching. In the next video I will discuss about the another application of it. Thanks for watching.